Find the derivative of each function. Before we find the derivative, we should take a moment to observe the given function to determine which rule, which shortcuts we will be using. We see that if we were to determine the value of this function, then we will need to multiply one factor e to another factor 4 raised to the 2x, which means this is the product, so we will use the product rule. Realizing that this is the product rule, it might look a little complicated here, so we will break it down to two factors. The first factor is u e to the 2x, and the second factor is v 4 raised to the 2x. The derivative of the product uv is u prime times v plus u times v prime. Now that we have u and v, we still need to find the derivative. Using the chain rule for u, because there is a function 2x inside the exponential function, u prime is the derivative of e to the anything is the same e to the same thing, but we need to multiply the derivative of that inside function, which is 2. And so u prime is 2 times e to the 2x. For v prime, there is a function 2x inside the exponential function with base 4. With base 4, the derivative of 4 to the 2x is 4 to the 2x times ln of 4. Since this is not base e, we have to multiply ln of the base, but we're not done yet. This function 2x is inside the exponential function with base 4, so we will still need to multiply the derivative of the inside function. The derivative of 2x is 2. And so v prime is 2 times 4 to the 2x power times ln of 4. Putting all of these together, we have g prime of x equals u prime, which is 2e to the 2x times v, which is 4 raised to 2x. U prime, and then keep v, but we're not done yet, plus the second term is u v prime, where u is e to the 2x, and v prime is 2 times 4 to the 2x times ln of 4. And we can leave the answer in that form. However, if we want to simplify this, then we can factor out the 2, we can factor out the factor e to the 2x, we can factor out the factor 4 to the 2x, and then we open the parentheses. For the first term, we factor out 2 already, e to the 2x, 4 to the 2x. There's nothing left, which means we need 1, because 1 times this expression will give us the first term. For the second term, we factor out e to the 2x, 2, 4 to the 2x. What we have left is ln of 4. For the second problem, we observe that this is a quotient. We have the top and the bottom, so we will use the quotient rule. Using the quotient rule, which states that u over v prime is, first we square the denominator, and then in the numerator, it is u prime times v minus u times v prime. We then let u be the top, 3 raised to the x squared, and the bottom is v equals x squared plus 1. We will need to find u prime and v prime, where u prime is, this is exponential, but we still need to use the chain rule because there is a function x squared inside the exponential function. This exponential function does not have base e, so don't forget to multiply ln of the base. The derivative of 3 raised to x squared is still 3 raised to x squared times ln of 3. And then using the chain rule, we multiply the derivative inside the derivative of x squared is 2x. v prime is 2x plus 0. And so h prime of x is, we first square the denominator, x squared plus 1, the whole quantity squared. In the numerator, u prime, which is 2x times ln of 3 times 3 to the x squared, times v, open the parentheses, x squared plus 1, minus u is 3 raised to x squared times v prime, which is 2x. And we can leave the answer in this form.